All right. Welcome back, everyone, to Virtual IoT and Edge Days 2022. My name is Frédéric Desbiens, and I manage IoT and Edge computing programs at the Eclipse Foundation, and I'll be the host for this afternoon's presentations. Okay, so our next presentation is about mining and specifically edge computing in the mining sector. Our presenter, Prasan Dutt, is senior IoT, embedded IoT engineer at Yash Technologies, is an embedded electronics major with 11 years of experience serving the embedded hardware and software industry, and he worked on projects that cover, that touch everything, but are not limited to IoT-enabled medical devices, wearable technologies, industrial IoT, scenarios like monitoring, predictive maintenance, etc. And he even worked on projects touching custom IoT gateways. He is a speaker, trainer, and mentor. It's my pleasure to have him today presenting. Now, for questions, please use the questions channel on the Swapcard platform to ask your questions. And at the end of the presentation, I will relay those questions to Prasan, and he'll be able to answer them. So Prasan, if you're ready, up to you.
Thanks, Frederick. Glad to be here, and thanks for the introduction. So myself, Prasan, and I am here to present important topic, interesting topic here, TSF monitoring IoT in mining sector. TSF stands here for Tailing Storage Facility, particularly a term widely used in mining sector. So TSF, as we can see in this image on the right side, a typical tailing storage facility looks like this. And in any mining industry, generally, once we start the mineral extraction process, there are several plannings and processes goes through, after which this tailing storage facilities are made. So typically a site generally looks like this, as shown in this left image. A mining excavation happens, then processing facilities it goes through. Then these tailing storage dams are made. These tailing storage dams have like water and tailing combination, and these are generally huge structures built to contain mine wastes. How the mine wastes basically comes? So any mineral extraction happens, it involves a heavy water chemical treatment on extracted ore, which results in basically the tailings. The tailings is basically tailing slug. It's a chemical mixed with water output, which is basically very toxic in nature, and it cannot be directly dumped into river and water bodies. So these slugs are stored in temporarily in a dam, and enough time is given for it to settle down on this in this dam, so that from top layer the water can be extracted out, and from the bottom, if once all this slug and everything settles down, then that can also be used by these mining companies. That also becomes useful after some years of settling down. There are different basically techniques associated with the design of these storage dams. However, failure to follow such techniques and lack of maintenance and monitoring results in TSF tailing storage failures. Such failure, there are several failures happened in history, and some major one I have mentioned here, like in 2019 in Muri, India, one bauxite mine TSF failure happened, in which approximately 35 acres of land was covered with red mud. In 2019, a major Brazil dam failure happened, which resulted in loss of 250 workers' life was, and 22 workers went missing. This failure basically happens through a very kind of long period of time, and recent in this year only in 2022, since January, three major incidents already happened. One in India, another is in Brazil, and another in some other country. So TSF failures basically have a huge impact on companies, monetary and otherwise. Let's have a look at one video in which, like this 2015 Brazil dam collapse, which I have mentioned. So it looks like this. This is a TSF facility, and you can see the footage of the moment when dam actually collapses. So you can see the structure, the huge structure becomes suddenly it goes a very kind of catastrophic situations it brings to the whole vicinity. And this looks like a residential area in which like so many people and such huge ecological damage also happened. So let's have a brief look at the mine, life of a mine. So in during initial 2 years of construction, there are several planning goes through that, and generally land is acquired after research findings that minerals are available at this location, and all the construction, all the facility construction planning goes through that. And then geospatial and geophysical and civil engineers basically give the plans how to uh, how to go for the extraction process and how to go for the mineral extraction and production process. So generally this is like this, like a location is chosen for the TSF, and generally it is in the vicinity of this whole production that location. So it is like this, and this what it is shown here. It is the tailings basically. It is stored in this, and this kind of dam arrangements is made. So once dam is made, and you can see like all the water discharge happens to this open pit kind of arrangement. And this is how this whole process of kind of mining life cycle goes through. And once this all it it finishes, then it is handed over, and it is the site is closed, and all further things are done. So you might ask the question, if such failure happens in TSF facility, then why not construct a concrete made dam or reservoir? Why companies design such uh, soil or land, or kind of like the land only extraction excavation they do, and based upon that they make these dams. So the thing is, TSF failure has impact on companies like monetary and otherwise. The point is, it is associated with useful life of the TSF. So because of these failures are very difficult, so actually mine owners use the term cause of failure dam. It's a black swan, which is extremely difficult to predict. It's very difficult to predict. So let's have a look at what are the type of dam types are there and storage techniques are there. It's majorly divided into three types: upstream, downstream, and centerline. Apart from that, hybrid, landform, and water retaining things are there. So back to the question, why not design a dam with concrete? Because because of economy and useful life of mining site plays an important role in dam construction decision. So once a excavation process start, the mineral excavation process start, the company owner do not know the useful life of operation, like how many years it will run. Maybe it will be 10 years, maybe it will be 20 years, 25 years, something like that. And they have to make the decisions so that they can get the particular profit. Any company work for the profit. Once they go for this, they spend so much billion of dollar in such mining operations. So they, according to the geophysical studies and all, they choose which kind of dam they have to make. And generally it is upstream, downstream, and central line. These kind of things are there. So let's have a look at the whole lifespan of this tailing storage facility. So you can see, like, this is a tailing storage, tailing ponds is there, and generally several factors are there, and mostly also it is associated with ecology and environment, and other factors like demographic factors are also in place. So you can see here, if this is the facility and heavy, wind are coming there. So this the dry area, the dry surface of this tailing ponds basically could bring tailing dusts to the residential area, which may contain some kind of contamination, some mineral which is very not good for health, and it might be mixed in food and water, which is not good. Apart from that, in raining during rainy season, it might bring acid rains, and it may mix with the tailing may mix with the river water as well. Increased risk of larger scale pollution incident due to extreme weather conditions, like if summer season is coming, some temperature, high temperature and low temperature is happening, then dam wall can also contract and expansion may happen, which will do a structural weakening. And the fact is, it is not visible through bare eyes. It happens very slowly, and the failure may happen very rapidly, and uh, suddenly it may happen without even noticing. So erosion and instability of embankment slope causes more intense weather events and patterns like rain, wind, hot, humid periods. Potential mass movement of embankment slopes due to increased precipitation also brings such situations, and it happens throughout this life cycle of lifespan of any TSF, tailing storage facility. So let's have a look at the cross-sectional view of what are the factors basically uh, are into place for any TSF failure. So it's a cross-sectional view of a TSF dam, tailing storage facility dam, and you can see several factors like cracking, low area and crest of dam, rodent activity, cracking may happen, the piping which is basically placed for this water outlet, which it it may happen, like erosion may happen there. The stability failure, it is an internal activity. It's a big, maybe because of seismic activity. And then seepage may also happen on in the contact of the land, the surface. And some boiling activity, some slump activity may also happen. So these are all the factors which may bring this tailing storage facility failure. So we did a research on this, deep research on this, and tried to find out what are the factors which are basically, what are the parameters which are coming into place, and then only we can design any solution which can prevent such situations. So there are, these factors are like earthquake, slope instability, seepage, erosion, subsidence, structural factors, foundational factors, overtopping. This all wagon wheel kind of factors are the regions for TSF failure, and the particular parameters which are responsible for these uh, factors are displacement, settlement, pore pressure, tension cracks for slope instability, earthquake, which may be happen for ground acceleration, settlement, pore pressure changes, etc., which may do these kind of changes. An earthquake event may do that. So with this, we are looking at an IoT solution, and we wanted to make a product which can detect, or which can give us the typical solution for preventing such catastrophic situations. So the concept is to collaborate and do in multiple engineering streams into picture, which is like combination of data engineering, data analytics and visualization, work and action management, reporting and compliance, and that will bring us give us the digital dashboard kind of uh, solution. Particularly for these parameters, we have to select the particular sensors which can detect or which can measure such parameters. For an example, piezometers will be used for hydraulic head poured water pressure. Settlement cell is based on the principle of 1D displacement. Surveying optical, which is based on the principle of monitoring parameter 3D displacement. Robotic automated, it's for 3D displacement, and so on and so forth. These are there are several factors, several parameters which are taken into account. We have a look at what are the technology trends which are going in the mining sector throughout the life cycle. So any life cycle of any mining site goes through exploration, development, exploitation, processing, transportation, sales, reclamation. Like once the useful life of operation of that particular site goes, after that reclamation is declared that we are done and we are closing that site. Then EHS is also there, which stands for environmental health and safety concerns, also taken into account, and then support function comes into picture. So for exploration, you can see like AI, ML, 3D modeling, autonomous equipment, nerve centers. These several technologies are used. IoT system is basically particularly used during exploitation, processing, transportation, and EHS. So this exploitation phase is also related to our TSF monitoring, tailing storage facility monitoring, because then only we do processing, and after that EHS also factors coming into picture, because EHS is concerned with environmental health and safety. So digital technologies transform decision making and improve visibility across mining chain value chain. So here we wanted to make our IoT enabled product which can give us a solution, and for which we are using drones and online cameras, IoT and cloud computing monitoring system, satellite imaging, connected piezometers, IoT enabled sensors, data management system, AI analytics, and TSF design models. And there will be a single platform which will be made, and it will give us all the information of dam wall deformation, dam wall movement, system, seismic and other vibration, dam and runoff water quality, seepage quantity and quality, and so on and so forth. Different measurement parameters will be available for us in a single dashboard integration platform. Particular areas of focus in IoT are considering like this is a mining site animation. So here you can see water is taken, and this is our processing facility in which water is taken, and here processing happens, and then uh, 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 after this process, such dry stacking, and also this is done. So our focus is to look into incoming tailing flows, incoming tailing properties, because whatever tailings which we are generating after the processing, it that property also need to be taken into account, because based upon that properties, like what kind of minerals are there, what kind of content is there, how many, what is the percentage of aluminum bauxite or corrosion causing minerals are there. So these properties, if it will be in history, if it will be in our data, then we may design such models which will be helpful for our predictions. We are also monitoring weather monitoring. We are doing TSF structure stability monitoring. We are doing TSF tailing and water level monitoring. We are doing inspection and review capture, compliance reporting, security monitoring. These things are also we are keeping into account. Dry tailing monitoring also we are doing. So once the tailings are are stored or processed, then we also take into account like how the dry tailings are happening. For example, when the tailing storage is filled with this tailings, and it is given some time to for the sediment to settle down, then the dry tailings are also monitored, so that on a long time term we can see how the changes are happening in the property of these tailings. Then surface and groundwater monitoring, water use monitoring, water quality monitoring, AQI, site surrounding environment tracking, relocation and rehabilitation, and further downstream soil quality monitoring also we are doing as a part of our IoT focus. This is a comprehensive list of the sensors which is basically used for tailing management. It is majorly it is into physical, environmental, and operational factors are there, and the particular risk associated with these segments are slope instability, seepage monitoring, internal inhalation, overtopping, and so on and so forth. So for slope instability, we are using IoT tilt meter in, in ISO interferometric synthetic aperture radar, which is used for tour, geodetic method to generate maps of the surface information. A piezometer is widely used. This is sensor which is put inside. Drill is made inside this TSF dams, the dikes on which we put these piezometers. It gives water level information and all. So, considering like what are the data sources for our this whole solution, so you can see gives a big picture of all the places on particular facility which is there. So, if this is a facility, for an example, we are placing this thermal monitoring, then seepage monitoring, satellite imagery. So these green ones are like sustainability monitoring, and the white ones are primary safety monitoring. So green ones are for safety monitoring, because any mining site, any mining company have to meet certain criteria for environmental factors. Like they have to submit the report uh, for this um, environmental, whether they are following all the standards or not. So apart from that, satellite imagery is also taken into account, so that by using satellite images we can do GIS based analysis, and on long term we can monitor the changes which are happening on these sites, particular sites. Water quality monitoring, air quality monitoring. Drone lidar is also placed, so that on maybe on weekly basis we can put drone into whole facility, because these facilities are very big facilities through ice, and such harsh environment is there that even the trucks and etc., like from through wheels we cannot reach those locations. So for that case we are using this drone and lidar imagery data for capturing that particular places for monitoring purpose. The images and videos are captured from there, and then further it is processed. Bore monitoring and other monitorings also doing it the similar way. So now we have all this data. What is the way to make whole sensor network and communication technology in place, so that we can design a perfect solution here? So the point here is like tailored selection of sensors and monitoring method as event, and the risk scores varies from site to site. In mining also it is told that every site is different from other site. So any site, if we are giving such solution, we need to closely see what factors are there, how the site is whether such sensors, some sensors we are placing, whether we will get useful life of that sensors and all. It may happen like uh, you know uh, it's a mining site, so there are chances like many kind of blast event happens on these sites. So it may happen like whatever sensor you are placing at particular location, you may need to shift after some time. So suppose that you have designed a solution in which you are placing some sensor here and it's communicating to my nearest gateway. But after you remove that sensor from that place or that device from that place, it may not be able to communicate to that gateway. So in that case, we need to design a solution so that adaptable network can be there as per changing site condition. Leverage sensor as a service, in which we are already using satellite images, drone technology, air quality monitoring, and whatever other services which directly gives us the sensor data, kind of, for which we don't need to place any sensors. For an example, this air quality monitoring, we can use the data from government sites, which is already giving us the data through APIs and all. And satellite images, already third party companies are there which gives us such information, and that we can use it for our all these computations and calculations. IoT mixed computing architecture also we are using for easier troubleshooting and scalable solution. So let's have a look at the architecture. Architecture is basically wholly fully divided into five parts, particularly IoT architecture. So at the ground level, we are starting from the mist layer, and in the mist layer, it is a combination of like all the sensors, nested piezometers, wired sensors, wireless sensors, and these sensors are basically sending the data to device edge, which is also a data logger. Data logger uh, captures all the information at this locally, and then further it is given to a gateway cloud edge gateway. And after this cloud edge gateway, we have this is again, it's a local kind of uh, edge gateway, and then it is sent to the fog layer. It may be, it's an optional thing, fog may be there or may not be there. It gives us the network based resiliency to our system, as GIS and AQI and weather predictions are also taken into account. And all this data goes to the cloud, and further our business cases, business logic is written there. Here, edge gateway is very important to be placed because uh, uh, there may be different any kind of technology at the edge, but edge gives us the any kind of action if we need to take locally without our data to reach on the cloud, then that we can do on the edge gateway. So again, let's have a look at the OT and IT kind of architecture from PLC SCADA and data sources to the cloud. So here we already talked about like sensors, data. It's not just sensor which is here in place, because it's an mining operation. So data may come from file system, it may come from data aggregators, it may come from handheld data collectors as well. So traditionally also and currently also it happened like the operation team goes to the site and they carry some handheld equipments which they used to do such measurement. So that compatibility should also be there in our whole solution. So all this information is going to this data sources, which is varying from like asset management, APS, environment, health, safety, fleet management. And historian is also saving the data from these PLC devices, SCADA devices, data lockers, and IoT devices. And all this data is going through this IoT edge, where OPC server client is also there in place. And we are leveraging MQTT, AMQP, HTTP protocols for sending our data to the cloud. So edge is a very important factor here to be placed, and we can use any kind of different services are available, either open source or managed services we can use here. And of course, we can leverage open source technologies here for making this working. So overall, our approach is to make first fix the basic, in which IoT based real time monitoring we are doing, document management system, workflow automation and compliance, and then we are raising the bar in which we are using latest technologies of AIML, TSF nerve centers and alarm notification. And then finally, we are changing the game through use of AR, VR, digital twins, and uh, advanced decision support system, using which our outcomes are to do prescriptive monitoring and management, insight driven monitoring and management, automated task and data capture, so that these events, the catastrophic failure, can be detected even before it happens. The platform features, it looks very extensive, but you can see the sources are all ERP, SCADA, cloud connectors, data historian, IoT devices. And at the ecosystem platform, we are using Edge Analytics, Edge Application Service, Edge Storage, Communication Management, IoT Gateway, Edge Serverless Compute. And on the data and analytics platform, we are using data management, data processing, AIML, cognitive services, storage, abstraction, and other services. We are leveraging data DevOps practices as well for developing this kind of solution, which is a combination of many technologies and many different engineering streams are there in places. So whatever solution is there, it's not like we need to continuously improve on that. So that DevOps practices also we are putting in place for this. So based upon all this information, I am here. I am giving a reference product overview, which we are integrating, and which will give you an insight of how this whole product, digital product, will actually look like. It's a kind of tailing insight plus tailing insight at cloud level as well. So it looks like this. So generally, in picture, you can see it's a web interface kind of uh, uh, map. And so in map, we can see how many vehicles are there, how many sensors are there. So you can see currently, like we can zoom in on the map and we can see uh, how many like sensors are there, and particularly for that sensor, what is the particular information which we are trying to look for. It's a kind of monitoring we are doing. So in map, if you wanted to see that particular sensor, we can go on that, and particularly data associated with that, we can see the voltage, the pressure, the ground temperature, and exactly at what time that sensor or device have sent the data to the cloud. All the information will be available on this dashboard page. Apart from that, here on any mining site, there are many cameras can be in place. So this product also uh, features such cameras. At one dashboard page, we can see whole site. Apart from that, it gives us the facility to add any kind of um, any kind of other parameters such as pressure, humidity information. So that also it is put in place, and then it is uh, customizable. In a sense, it is also customizable. So this is how it looks like. Apart from this web interface, there is mobile interface also. So the operators, the supervisors who are in field for this um, uh, facilities, the mining, and they have mobile apps also, so that they don't need to go to a computer to see all the things happening. Suppose that they're in the field and they wanted to monitor a particular sensor, so they can just go to that place and any place, and they can uh, use their mobile phone to log in into dashboard, and particular sensor information also they can get, and particularly graphical information, historical data, battery voltage, temperature, pressure, everything they can get from a single page. So What is the benefit we are getting out of this digital product? There are several benefits, majorly two parts. It can be divided: tangible benefits and intangible benefits. Tangible benefits in terms of economic, environmental, health and safety, and reputation. So tangible benefit could be like, of course, loss of production due to, we can avoid such situation, avoid such catastrophic failure. And once this situation will not come, of course, a hefty fine can be avoided, because once such a situation happen, it may result in very hefty fines for the mining companies. It will also avoid any kind of environmental ecological damage which may happen. It will also avoid loss of lives, injuries to workers, people, due to such failures. Reputation of companies, mining companies, is they take it very seriously. It's very important because a contract is in place for such mining operation, and if such TSF failure happen, it may bring down their reputation, and they may lose the contract as well. So such tangible benefit will also be helpful for these mining companies. Intangible benefits could include in terms of economic, such as they can avoid effort in manual planning and execution for repair and maintenance that they need to do anyhow regularly. Environmental wise, it will increase the ecological, flora and fauna could be improved more than that. Then uh, even though mining operations are going on, the ecological sustainability will be in place. Health and safety wise, mining companies have to live with the close habitant, so that once the relation with the local habitant will be good, then it will be also for good for their smooth operations. Reputation wise, of course, they can enhance the reputation, as well as such product other mining companies can also use, and it will bring the reputation and tangible benefit. So with this, I would like to take any question, and thanks for listening to me.
All right, excellent. Thank you so much for this great presentation, Prasan. So we have several questions, starting with a few from Alexander. So he's asking, what is the strategy specifically to choose the location for various sensors when you have such a large area to cover? This means maybe you need to deploy lots and lots of them. So can you elaborate a bit on that?
Yeah, excellent question. So basically here, and the geophysical, basically, engineering is and civil engineering is very much widely used. We take, as a data implementers or as a solution provider, we take the input from these engineers, is these uh, practices, and based upon their recommendation we place these sensors. So they give us the recommendation that such, depending upon the seismic activity, how the geography is there, and how the dams are constructed. So they gives us the information that this place they need to uh, place the sensor. For an example, I can take the reference from another industry, like not industry, but in building monitoring, a structural monitoring. For an example, in bridges also we put the piezoelectric sensor. So generally, once the foundation starts, they put very small this vibrating wire piezometer during the construction period itself. They put on the columns, and uh, it gives the data in long term. So yeah, keeping short, we take the information from geophysical and civil engineering to place our sensors.
All right. Thank you for this answer. So I think the short version is you need engineers, in mining or whatever you are doing, instead of just doing that with IT people.
Yeah, yeah, it's not possible for IT people to do in such multi engineering.
All right. Second question from Alexander. So it's asking about the distances between your sensors and edge devices and your gateways, and then from the gateways to the central server. What's typical in the deployments you worked on?
Yep. So here, like our practices of networking is in place. So as I have mentioned, like two kinds of we use several communication technologies. It could be wired and wireless. So typically in these cases we use LoRa, long range communication, because typical these sites are very big sites, and using kind of other technologies like we also need to bring down the cost, as well as we need to bring the benefit to the to the low cost of implementation could happen. So LoRa wave, Bluetooth BLE, and uh, and these are the popular you know networking options we are using. So from our mist layer to okay okay, I cannot show the presentation, but from our mist layer to the data logger, we use Wi-Fi, BLE, and wired. And from our device edge to cloud edge, we use LoRa and uh, uh, Wi-Fi as well, mostly LoRa. And from cloud edge to our cloud, actual cloud, we use 3G, 4G, and because it's a mining site, so it's possible like the network is not available at all. So our last option is satellite link, so that data can directly go from through satellite to the cloud.
Yes, that makes sense. Okay. Another very quick question. So on one slide, you were mentioning on your infrastructure slide AMQT, and maybe that's a typo. Were you referring to AMQP instead? Okay, that's the case. Thank you. Um, a question from Mohammed now is asking if you're using any Eclipse open source technologies in your platform, such as Eclipse Ditto or Hono or any of your projects. So, can you comment on that?
Okay. Eclipse good supporter of open source. We are using all Azure based solutions. We have a very like verified and like tested this IO fog for our edge management, which is again from Eclipse only, IO fog. So that framework we are and we have used in somewhere. Yeah, IO fog.
Okay, and that's a nice segue to our next presentation, since the speaker after you is Kilton Hopkins from Edgeworks, and he will tell us everything about the upcoming IOFOG 3.0 release. Last question, in this case from Miguel. He's asking, are you using open source devices like the Arduino for prototyping when you're thinking, I suppose, mostly about the hardware parts of the projects?
Okay. Generally, this kind of solutions are very and we need to meet certain standards, certain you know um, uh, parameters are there, so that for enterprise application we don't go for such open source hardware. Yeah.
Okay, that makes sense, and it makes sense when you think about the fact that you need this hardware to be ruggedized and
Mhm.
water resistant or dust resistant in some cases, and all of that. So you need you need to pay a bit more in order to get the quality you require for the project. All right, so that would be it for this session. Thank you so much, Razan, for submitting and presenting at the Virtual IoT and Edge Days. Really appreciate it.